just like we have red and blue in unified namespace. Red is our standardized namespaces, and blue is our ad hoc namespaces. And maybe it's something unique to one production line or whatever. You're going to need to support the same type of relationships in a knowledge graph. Number two, they understand the difference between the real-time state that is in unified namespace and how real-time is used to drive other decisions. For example, is you are going to be publishing the standard definition of that PLC's relationship in the graph, number one, and that's just going to be native. So then it's just going to show up there. They asked the agent to do a root cause analysis on a very specific anomaly that they were seeing. They said, I want you to do the RCA and I want you to format it in this format. And it spit out the RCA document with the interventions, something that you would actually use agents for. And what the agent's going to do is look at current state, and then it's going to look at the context in the current state. And it's going to go, I need a little bit more information. I see this production line is running, they're behind schedule. I think the first thing I need to do is I need to take what I've got there at current state, and I need to go query the old work orders. Unified namespace gives you the answer to what the current state of my area is right now. If I say, what work orders are the highest performers right now, unified namespace is the backbone where I go get that.
So it was only natural also for me to see this as the natural sort of backbone for AI agents, which are effectively microservices, as it were, that perform a specific task, right? And then they're plugged into that state and event infrastructure to receive the context on what they need to do next, and then go off and do whatever it is that they need to do using MCP or whatever it is.
Correct. Those were two examples at ProveIt specifically where I was like, whoa.
Welcome to the AI in Manufacturing podcast here on Industry 4.0 I'm your host, Kudzai Manditereza. And today I'm joined by none other than Holker D. Reynolds, who is the president and solutions architect at 4.0 Solutions and the founder of the ProveIt Conference. So, Holker, welcome to the show. Thank you so much for joining. It's great to have you back on the show.
Thanks, brother. I appreciate you, man.
Absolutely. So before I let you introduce, yourself, I'd like to kind of like give our audience a quick overview of what we hope to cover in this session. So the ProveIt Conference just wrapped up about 2 weeks back, right? And given that this podcast is really all about AI in manufacturing, I thought, who better to talk to about what's going on in our industry as far as AI-powered solutions are concerned than Holker Reynolds, based on what you saw at this year's event, talking to people, and also what you saw on the floor. Secondly, the unified namespace has seen a real wave of adoption over the past few years. I think I last heard you on the podcast about 2 years back, and sort of like the rate at which it has been adopted across the industry has been really mind blowing. So I thought maybe this is also an opportunity for us to kind of like get this as a milestone and say, where do we sit currently? So I've had some feedback from some people who are saying, they're not getting results from the unified namespace. Some are getting some tremendous success. So I want to get your sense on what the former is doing wrong, and what the other group is doing right. And then of course, agentic AI is a big topic, right? So we're going to explore, what role the unified namespace actually plays in making agentic operations a reality. And then to close this out, we're going to sort of like zoom out and get a Holker's vision on the ideal industrial data architecture. What does that full stack look like for manufacturers who want to maximize value from their data and AI investments? So with that, Holker, I know most of our audience here would already know who you are, but for anyone tuning in for the first time or anyone who's discovering your work for the first time, why don't you take a moment to introduce yourself and give us a bit of your background?
Well, it's funny you say that. So so before I introduce myself, when I'm on the road, if I'm giving a speech or something, so most of the time, like I'll get hired to do a keynote, and when I come down off stage, there'll always be people like kind of in a line to take photos and have conversations, and they'll always introduce themselves. They'll say, "Hey, I'm Sarah," or "I'm Bill," or whatever. And I will shake my hand and say, "Hey, I'm Walker." And I always introduce myself as Walker, and people will say, "Yeah, I know who you are." And my team constantly asks me, why do I do that? And I go, well, because in my head, I don't assume everyone knows who I am. Like in my
100%.
brain, I don't think that way. So I generally start every conversation under the assumption no one knows who I am at all. So
100%.
I'm Walker Reynolds. I'm a solutions architect, really. At my core, I'm a solutions architect. I'm an educator. I've been a senior engineer in systems integration for 2 decades. I'm an executive. I spent the first half of my career working in manufacturing in a salt mine, and then the printing industry, and then the steel industry, and then tier 1 automotive. And then I pivoted to systems integration. I worked for 2 of the most well-known integrators in the world, smaller integrators, but very, very highly esteemed. And then I started my own firm in 2015. I'm mostly known for the architecture of unified namespace, and I'm known for what we do on YouTube. In 2018, we started producing YouTube content, kind of explaining to the market, hey, here's what you're doing wrong when it comes to digital transformation. Like, everybody's making the exact same mistakes. Please stop making these mistakes. And the goal wasn't anything other than our engineers were getting tired of fixing the same mistakes. And I wanted to lower, I didn't want turnover to be really high. And that ultimately translated into this online presence, podcasts. And I run IIoT.university. We have a mastermind program. We have integrator growth program. We have mentorship. We manage a Discord server of about 8,000 people. We have 14,000 students at IIoT.university. And then at 4.0 Solutions, we just launched an e-commerce site where vendors can sell their software directly to the end users at new pricing models. So basically, we're supporting people learning how to use platforms through education and access to licenses through our e-commerce site, which is what we're focused on now. So anyway, that's who I am. And then the ProveIt Conference came from 2 years ago, coming back from Hannover Messe, and I was like, man, this was a waste of time. Like, Hannover Messe could be so much better. It's a huge show, but I didn't get really basically any value out of it, because the traditional conference is all about marketing features and benefits. It isn't about talking about problems. It's not as an engineer, you can't go to a conference and ask technical questions. They always go, well, I've got to get you with a sales tech or whatever. It's some marketing person who doesn't know anything about the problem that you're trying to solve. The ProveIt Conference was designed to be the conference that engineers go to see solutions side by side on a common infrastructure, and then ask very detailed technical questions about software and hardware and solutions.
Absolutely. I mean, it's amazing, work that you've done with the ProveIt conference. Only in its second installation already, I think it has become one of those events that the industry is really watching close. And in my opinion, really, it's kind of like become sort of like a barometer of where manufacturing is actually headed. So now that this event for this year is in the books, I wanted to get your sort of like honest read on the state of the industry based on the conversation that you had, or some solutions that you saw at the conference.
It's my opinions are going to be a little controversial, which I think you're used to. All right, so I have 3 core observations. Observation number 1 is that most vendors are moving much faster with their offerings than the market's ready for. So AI fatigue is really setting in. Many vendors are, they're incorporating agentic AI into their solutions without really understanding what problem they're trying to solve with agentic AI. The point number 2, to follow up on that piece, is that most end users are still asking themselves, where do I start? They're not asking themselves, how can I use AI to optimize operations? There are some end users who are, but what's happening is the tails of the bell curve are getting further and further apart. So those who are least mature are further and further away from the mean than they've ever been. And those who are most digitally mature are further and further away from the mean than they've ever been. But still 98% of people are within 2 standard deviations of the mean. And most of them are asking the question, where do I start? And so the one of the biggest observations is, and I talk to a lot of young engineers, a lot of young developers. I talked to every vendor. I talked to, we had over 1,000 people at the show. 70% were end users. So 70% of the attendees worked in manufacturing, and 30% were vendors and stuff. I talked to a lot of developers. I talked to a lot of end users, and so many of them were just sick of the agentic AI solution that to them is like, I would never use that. Like that's somebody who built something that is not useful for me. They don't even know why they built that. They just built it because they wanted, it's kind of like with UNS adoption with some companies who get the definition of UNS wrong. They know UNS is popular, so they want UNS, the name UNS, to be on their product. They don't even really know what UNS is. The same thing is happening with a lot of vendors. They really don't know. We're still so early with agentic AI. They really don't even know how agentic AI is going to be valuable to manufacturing. And then there's some, like just crazy pipe dreams out there. Like we're going to use agents to do, handle all the automation and, and it's all, it's lunacy. Manufacturing is so unique and diverse, and, you can't, I want people to try and do automation with agents just so we can reveal how ridiculous of an idea that actually is. And then the third piece is, and I would say this is the big one that I think really stood out. Okay. And that is coming out of the ProveIt conference. Going into the ProveIt conference, there were a lot of people like the most gifted engineers out there, the gifted architects, the Jeff Noonans of the world, the Jeff Noonan from Rise, like Rick Bellotta understood this. Super Matt Paris, Jeff Schrader, like the really Jeff Schrader from HighByte, Matt Paris from GE Appliances. People who are on the bleeding edge of the tech, they understood the importance of knowledge graphs. Like they really understood, okay, knowledge graphs are going to play a huge role in how we unlock the potential of AI. The vast majority of people who came out of ProveIt understood, even the average layperson understood coming out of the conference, wow, knowledge graphs are things I need to brush up on. Knowledge graphs are a game changer. So knowledge graphs, which is just basically relational context, the relationship between nodes in any intelligent system, they're critical for unlocking AI through people. So if at the end of the day, knowledge graphs are going to be used by AI agents to navigate up and down the infrastructure of a business. So say I have an agent at layer 3, and I know HiveMQ is working on a lot of this stuff. So say I've got an agent at layer 3, so in the MES layer, and we have a rising edge of some anomaly that we're detecting. Hey, we're seeing decreasing OEE, or we're 45 minutes behind schedule on this work order. Well, the obvious question is why are we 45 minutes behind? And what do I need to change about my schedule? What interventions do I need to take? And what do I need to change in my business to make up that 45 minutes, right? That's what businesses do all the time. Well, if we want to use agents to help us with that, the agent is going to be given the objective at layer 3, whether you're going to do that on a rising edge or where the agent it's triggered and the agent just takes over, or a human being interacts with the agent and triggers it. The agent's going to move into level 3 in the MES layer, and then it's literally going to navigate down through a knowledge graph, and it's going to reason through a knowledge graph to get to the location in your infrastructure where the answer to the questions actually live. People are really understanding now, coming out of ProveIt, just how big of a role knowledge graphs are going to play. And I think Thread did the absolute best job. There were many examples of knowledge graphs. i3X, obviously, the i3X announcement from Sesame was a huge one, and they had a big knowledge graph in their demo. But I think Thread Cloud did the best job of showing the power of knowledge graphs and how they did a root cause analysis use case that was it was mind-blowing. I mean, it was just, I think a lot of people walked out of there. It was very practical, and they were like, I get it. Like, I really get how this could be used. So those are my big 3 takeaways.
100%. Yeah, it's very interesting that you mention knowledge graphs, because that's also the trend that I've seen, that knowledge graphs are actually going to be huge for manufacturing or industrial AI, as it were. And I think so. The companies that, because knowledge graph are such a huge sort of like shift into how we already understand how to manage data, especially in manufacturing, right? So it's I think the solutions that are actually going to sort of like dominate in this space are the ones that are going to make it easy to work with knowledge graph. That doesn't require, because there's a huge,
it's going to be native
graph.
A knowledge graph is just going to be native to the connection. Like we use HighByte. HighByte's a data ops platform, and I really love HighByte. But one of the complaints that I have about not HighByte is that there is no, if you look at HighByte has inputs. So it has inputs, it has models, it has flows, it has pipelines, it has outputs, right? Okay. You're basically doing data operations. There's no place inside of HighByte that shows you the relationship visually to an input all the way through to the output. There's nothing showing you the relationship. That would be a knowledge graph. That would give me the ability to see how this input is used in other places in the platform before it gets to the output, before it gets pumped to Snowflake. Where knowledge graphs are really going to be used, they've existed for a really long time. If you heard GraphQL or all these things that you used to hear are designed to drive knowledge graphs, or they use knowledge graphs to yield the output. The average person didn't understand why they were important. Coming out of ProveIt, people now, and it's agentic AI that's driving the importance of knowledge graphs. There were really, really gifted architects years ago who were like, hey, this stuff matters, but they couldn't explain to the market why it matters. One of the things that came out of ProveIt was people understand now why they matter. And so knowledge graphs are just going to be native to every platform. Like if you can't visualize the relationship between all of the entities inside of a platform, that platform will not be useful to an agent, because an agent is going to have to be able to move through that knowledge within a platform to answer whatever question or to meet whatever objective.
100%. And I think one of the concepts that I really found fascinating. So I heard Zach Edia last week on the podcast here. He talked about this idea of federated knowledge graphs, because we still have the challenge where we talk about this idea of ontologies and knowledge graphs, and we're still approaching it from this top-down mentality where we imagine that there's going to be one sort of like team at the top that is going to define how it is that the manufacturing works. But what's going to actually work is empowering sort of like the OT users to be able to sort of like build those connections or make those connections and sort of like federate that knowledge from the bottom up, right? Otherwise you're not going to model the entire factory or the whole.
And what's even crazier, so it's going to be native. So when you take a node like a PLC and you plug a node into an infrastructure, one of the first things that you want to do with that node in the future is you are going to be publishing the standard definition of that PLC's relationship in the graph, number one, and that's just going to be native. So then it's just going to show up there. Number two, just like we have red and blue in unified namespace, red is our standardized namespaces and blue is our ad hoc namespaces. And maybe it's something unique to one production line or whatever. You're going to need to support the same type of relationships in a knowledge graph. So you're going to need to support standardized relationships, and you're going to need to be able to support ad hoc relationships. And I'm going to take it back to Thread Cloud. One of the reasons I'm so impressed with Thread is Thread supports many types of relationships in their knowledge graph. So you actually, when you create a relationship, you define the relationship type. And one of the types is ad hoc, like a non-standardized relationship. 100%. So I think the big thing people need to take away is what people should be working on right now is improving their fluency on what knowledge graphs actually are. So not just the word knowledge graph, but what does a knowledge graph look like? How are relationships handled? And why are they important in ontology? Like, I think you just need to, that's where everyone should be working right now. You're going to need, just like you needed to know a year ago, you needed to know MCP. You needed to know how model context protocol works a year ago. This year, your homework is learn knowledge graphs because you're going to need them.
Oh yeah, 100%. Yeah, so I want to kind of like take a step back to, I think you mentioned one of the, interesting things that I've also been observing, this tension, between what's technically impressive and what's practically useful on the plan for as far as AI or agentic AI is concerned. Yep. So I kind of like want to get your sense on, do you have those top 3 or 5, AI powered solutions that maybe you saw at ProveIt that you think are kind of like get it or doing kind of like going the right way?
So there's really, I'm going to use, so I have 5 of them. Mm-hmm. The first one I'm going to start with is using AI to drive development. So that is using agents inside of platforms so that I can use natural language to speed up the development of some solution in a platform. So WinCCOA demonstrated this incredibly well. Siemens demonstrated this incredibly well. TatSoft demonstrated this incredibly well. Okay. Those were 2 examples at ProveIt specifically where I was like, whoa. Okay. And I had a chance to get a sneak peek into WinCCOAs before the show. I hadn't seen TatSoft's yet. And I got to see TatSoft's at the show. And I thought both of them are showing very practical ways how you can use agents to speed up integration inside of a platform. Okay. That's number one. Because it's very practical. Anyone can look at it and go, that makes sense. That's something I would do. All right. Number 2, Atanta Analytics, which is kind of an extension of what TatSoft and WinCCOA. So Atanta Analytics is they're based out of Germany. I think they're a combination of India and Germany, but I know the owners and stuff are in Germany. They have a partnership with Mitsubishi on their analytics platform. And basically it's a citizen developer analytics platform. Well, what Atanta did was they created Prompt to Insights, which is a new offering of their analytics platform, where you're using agentic AI, native language, to enable citizen developers to build analytics dashboards. And their demo, it was absolutely something. If you're watching the presentation, you're like, I would do that. Like, that would make my job so much easier. Like, Atanta's kind of claim to fame was that they really figured out how to do dashboarding really well. Believe it or not, a lot of platforms don't have dashboarding tools in them because dashboarding's not easy. If you're going to write it as software, it's actually really hard to do. It's not easy to do. That's why there's so many platforms out there like Node-RED that don't have a dashboarding layer, because doing dashboard is like so unbelievably hard. Atanta Analytics really figured out how to do it in a very easy way. They incorporated knowledge graphs into the platform so you can see the relationship of connect, transform, visualize. But the big thing is Prompt to Insights gives you the ability to basically talk to an agent about your data and then build a dashboard that's reusable and redeployable inside of Prompt to Insights. And I was very impressed there. Thread Cloud, I think of all the companies who did stuff with AI, I think Thread just crushed it. I mean, they were standing room only. What was even worse was Thread Cloud they were a silver sponsor and they were up against Yukodyne. And Yukodyne did this incredible edge-based AI solution that I'm actually going to be doing a reaction video to, because there was nobody in there watching because everybody was over where they were watching Thread. The whole room was packed for Thread. Yeah. And Thread got applause in the middle of the presentation, which never happens. Okay. And they basically used AI. They used knowledge graphs to drive AI analysis. So the agent that they were using, they asked the agent to do a root cause analysis on a very specific anomaly that they were seeing. They said, I want you to do the RCA and I want you to format it in this format. And it spit out the RCA document with the interventions, something that you would actually use agents for. It was a phenomenal presentation. And then one that I thought was really interesting, and it's not something you would do today. You wouldn't use AI for it today. But the big thing with Maestro Hub did they basically had Claude Code write a module for their platform during their presentation. They had it write a MySQL connector for their platform in 21 minutes. Now, the market is not ready to be writing modules using Claude Code for something you're going to run in operations, right? Where the appetite's just not there. But the art of the possible was there. You were like, okay, I see that. That's where we're going. Oh, that's how Claude Code works. Oh, you mean Claude is a senior developer, a junior developer, and everything all in one. And if I give it the right context, I can give it the documents to an SDK and it can write modules for me. I think a lot of people walked away with that going, whoa, okay. And then the last thing is, and I think this is kind of right now where people are getting the biggest bang for their buck in AI, is using artificial intelligence in business workflows. Okay. Mm-hmm. So I don't know how much we're allowed to share, but I mean, everybody knows that HiveMQ, for example, is moving from a data platform to an information platform with Pulse, but really their future is AI enablement. They're going to an AI enablement platform. And I have had a chance to see basically 3 AI solutions that I think are very impressive. And I'll talk about 2 of them I can mention. Yeah. So one of them is Make Yourself AI, My AI, which is done by the guy from Tulip, who left Tulip. But the Make Yourself AI, if you get a chance to see the demo there, it'll blow your mind. I mean, basically, agents building their workflows on the fly to solve your problems. Okay. And then I've had a chance to see what it is you guys are doing. Yeah. And right now, when you're using AI in business workflows, most people are using N8N, right? They're basically building a workflow, and then they're like injecting. When you get to the 3rd step, we're going to ask an agent to do something at the 3rd step and return something to the 3rd step, and then the workflow will continue. And I think N8N does a pretty shitty job of that. It does a really good job of building a business workflow, or it does a really good job of putting the agent in the workflow, but it doesn't do a good job of creating really practical, flexible workflows, like decision trees in a manufacturing environment. Where you guys are doing something, what you guys are doing in your platform, and I'm not going to share what it is you're doing, but there's one thing that you guys are doing that is a complete game changer in the way that AI is going to be used, and that is this. Workflows need to exist inside of a specific agent, and many agents should work together to create workflows. And so one of the things you were talking about with the knowledge graphs earlier, yep, what we were talking about with knowledge graphs, not everyone is going to be able to understand how a knowledge graph works. Also, not everyone's going to be able to understand why it's important to have workflows on a specific agent inside the agent itself, but also workflows in, if I go from step 1, step 2, 3, 4, 5, and I'm using a different agent at each step in a business workflow, I want workflows inside the agent, which basically tell the agent how to reason. Right now, when you use an agent and you connect it to an MCP server and you ask it a question, the agent creates its workflow on the fly. I'm gonna use this tool. I'm gonna go select these machines. Then I'm gonna look up. It's using the large language model to come up with the reasoning steps, and the reasoning steps are the workflow. One of the things that's missing is giving me, the engineer, the ability to predefine part of the workflow for the agent to go through when the agent is trying to meet the objective. You guys are doing that. But one of the things I want to talk about, the knowledge graphs and that piece. Yeah. It's like when you go from, one of the things that we're discovering in our industry is that not everyone's able to make the leap to the next technological capability, right? It's like when we were taking math in high school. Yeah. Not everybody could go from algebra to calculus, right? It's like when you go to calculus, you have to be able to all math that you do until you get to calculus is in 2 dimensions, right? It's X and Y axis, and that's it. Calculus is 3-dimensional. You have to be able to think of a math problem in calculus in 3 dimensions. When you get to imaginary numbers, you have to be able to think in unlimited dimensions. Not everyone can make the jump from algebra to calculus. And not everyone can make the jump from using a chatbot, Claude, to using agents in workflows across agent-to-agent protocol and using model context protocol to navigate through a knowledge graph to find the location where the context exists in order to meet some objective. That's part of where we are, is that not everyone is able to make the leap. And the question is, if you're a manufacturer who doesn't have someone to make that leap for you, what happens to you? Like, if there isn't someone in your organization who can make that jump, who's going to be able to understand why knowledge graphs are important for you, or is going to be able to understand why it is putting a workflow on an agent is important. That is being able to at least predefine the first 3 steps you want the agent to go through. Why that's important. What's going to happen to you? That's kind of where we are.
100%. And I think right now, it for a lot of manufacturers, it may not be clear on exactly how, agentic AI or AI agent help them. But this is also the opportunity to start, building up that fluency, that AI fluency. Correct. To understand all of these things. What are skills? What is MCP? What are knowledge graphs, right? Because by the time it really starts, to pay off, all those who've kind of like built up that muscle of, understanding AI, setting up the infrastructure, are the ones who are actually going to, really gain that competitive advantage.
One of the things I was talking about when ChatGPT first came out in what I think it was November of 23, right? Yeah, November of 2023 or 22, whatever year it was. The following January, so 2 months later, I went to my team and I could see, hey, I don't know how this is going to be used, but I know it's going to be used. I know we're going to be using it. And in order for us to unlock the potential of this, we're going to have to improve our fluency in this technology. And so I gave a directive to my team, starting Monday, all of you are going to go buy a vertical monitor, and you're going to open a chatbot in the left-hand screen, and you're going to be working with that chatbot all day, every day. You're now an AI supervisor. I don't know what you're going to do with it, but you're going to use it. And the reason why was I said, I want you to focus on improving your fluency on this technology. I just want you to understand it. I want you to play with it. I want you to kick the tires. I want you to come back to me and tell me where it's useful and where it's not useful. And one of the things that we've now been able to determine is if you look at someone's fluency when it comes to agentic AI, when it comes to large language models specifically, everybody's going through the same process. So process number 1 is the first time they use a chatbot, they treat it like Google, right? They talk to it as if it's Google. They put in the exact same prompt that they would put into a search bar in Google. Then they realize, well, that's not really unlocking, I could do so much more here. So then it's, what I really wanted to do is I kind of want this chatbot to be a person. So what I'm going to do is I'm going to tell it who it is. I'm going to tell it what its expertise is. I'm going to tell it how many years of experience it has. I'm going to tell it what it believes. And then I'm going to ask it lots of questions, and I want it to give me the answer in the perspective of that person, right? And then it goes on and on. And like there are steps to fluency when it comes to AI. Right now, the vast majority of people aren't fluent at all. They're still using it like Google. And what manufacturer needs to be doing, that's why they're still asking the question, where do I start? The end users are saying, where do I start? Even though all the vendors are showing AI features, and they're going, well, I don't need that. I don't even have the data that the AI could use yet. I don't even have the data yet. It doesn't live somewhere. I don't have a unified namespace. Where do I start? The thing is even if you haven't started, you still got to be working on your fluency with AI.
100%. So I just want to quickly, go back to, like your top 5 list. And clearly there's a pattern, like you mentioned here. AI, agentic AI is currently good for building, right? Building workflows, building code, building this and that, which is not surprising because even in software industry, this is exactly what, where you're getting a lot of value from. And I think also, for me, I think it's also because a lot of agents currently only have access to the data that's within that specific application. It can only trust the data that is within that specific application.
Its context is very, very limited.
You need to have that backbone that can actually provide context across multiple systems, solutions and things like that, so that that you could actually work off of an objective function, right? You've got an agent that you say, I want to increase OEE by this much %, right? Because they're working off of the same backbone. This is something that is achievable as agents start to interact with each other. So I think that's basically something that we're going to see as we move along, to start to see more AI agents being built more for sort of like for operational tasks, as it were, rather than just
no question.
solutions.
And the only caveat I would say is human supervisable operational tasks. I would say the big place, or the concept that I think most people are struggling with is, I think they want agents to be autonomous. You hear this all the time, autonomous agents. And all I keep thinking, it's the only person who believes agents can run autonomously are people who don't work with agents. Because if you work with agents, you realize just how unreliable agents actually are. Like there are two limiting factors. Limiting factor number one is, what is an agent? It's an agent. The models that agents operate off of are confused. I think, Claude has done a very good job on the coding side. Gemini's done a very good job on the writing side. I think Gemini's superior at doing like technical documentation. ChatGPT is a very good Swiss Army knife, but it's not really great at anything, but it's good. Microsoft's Copilot is a complete disaster. It couldn't possibly have gone worse. It's going to go down as one of Microsoft's greatest failures of all time. The problem is the language that these models are trained on has conflicts in it. So, for example, you have people out there who believe the Earth is flat. Okay. And then you have academic papers out there that say that the Earth is round. Okay. And then you have papers out there that say the Earth is 4,000 years old. And then you got papers out there that say that the Earth is 5 billion years old, right? The universe is 5 billion years. The point is that the data that these models are trained on has native conflicts inside of it. Not every single thing, not all of the language that these models are trained on truth. So because they're not trained on truth, in many places they're trained on speculation, they're trained on opinion, they're trained on propaganda. The outcomes aren't 100% reliable. They aren't 100% reliable, and so therefore agents are not going to be autonomous. The most reliable large language models right now are 99.9% reliable, and that sounds very reliable. No, that's one error in every 1,000 words. Okay, that's not reliable. That's not that reliable. A PLC has 9 nines of reliability. A PLC was designed for automation. Okay, it has 9 nines of reliability. That means if it didn't fail physically, it would run for more than the history of the universe before it had a single failure. Okay, an agent can't run for minutes without having an error. And so that means it can't be relied upon to be autonomous. And unless we have a better mechanism for training models on truth and not just speculation and opinion and all the garbage that's out there in the world, they're not going to get much more reliable. We're seeing diminishing returns when it comes to our large language models. We're seeing exponential returns in things like Claude Code, but we are not seeing exponential returns in the large language models. Like GPT 5.1 to 5.2 was not an exponential return. It was a diminishing return. So we know we're getting to the ceiling of the large language models right now. So if you're a manufacturer out there listening, get it out of your head that agents are going to run autonomously, okay? They are going to be human supervised. And so think of agents as a force multiplier for your workforce, a way of unlocking the potential in people. Because if you think otherwise, you are wasting your money. That's a mathematical certainty that you are wasting your money if you think agents are going to run autonomously.
100%. And I think that also kind of like, what you just mentioned about this idea of agents being trained on different, truths, as it were. Right. And this also makes it, very, knowledge graphs very important here, right, because of the ability to allow you to create causal models. Because to your point, explainable AI becomes irrelevant in this case, because an AI agent can explain to you, I did this because of A, B, C, and D, but the explanation doesn't really help because it's not the truth, right? Correct. But with the causal models, you actually you can build a chain of reasoning within that model, right? To say an operator can actually safely act on a recommendation from an agent, because it's
Correct.
not just an explanation, it's a causal chain of reasoning that is actually governed, by the enterprise.
And what's even crazy, we hear, and now take it one step further, right? You can use AI agents to propose a causal model and have the human being approve the causal model. That is using a force, that's using agents as a force multiplier. Instead of me having to sit down and design from scratch a causal model, it's just like, I say this all the time. If you ever want, let's say you go to an executive, Barry Liebert is your CEO, right? If you were to go to Barry and you wanted Barry to make a decision for you, let's say you were gonna Barry is ultimately going to make the decision about the future of the AI platform you guys are building. You could go to Barry and say to Barry, hey, Barry, I need you to give me the future of this AI platform. Tell me what it is you envision. Tell me what it is you want us to build. And Barry would have to take the time out of his schedule, a couple of days, sit down, brainstorm it, whiteboard it. He'd have to put it down on paper. And so the likelihood that he's going to do that, because he's the CEO and he's a busy guy, is very, very low. But what you could do is you could come to Barry with 3 options. You could brainstorm 3 different options for the future and come to Barry and ask Barry to review the 3 options and choose one. And that would lower the barrier to entry to make the progress. That is the power of agents. The power of agents is using agents to give us options to choose from. Okay. And it speeds up. We become supervisors of AI. That is where we're going. That is, if you want to know how to unlock the potential in artificial intelligence right now, that is the place. But most of you are not ready, because most of you don't have the data connected together, wired together in context and normalized for agents to actually use on your behalf. And that's where the whole UNS discussion comes in.
100%. I think that's actually a good segue to talk about the unified namespace. So, as I mentioned, at the beginning of the talk here, unified namespace has really, achieved some significant adoption, right? And you have had a front row seat, watching all this, UNS adoption evolve over the past years. So, as I mentioned, we're in sort of getting some, reports, some saying we're not actually getting value from the unified namespace, some actually achieving some, tremendous success. So, when you look at, manufacturers who are actually genuinely succeeding with the unified namespace, what is the real differentiator and what are the others doing wrong?
All right. First and foremost, the fundamental difference between getting value out of UNS and not getting value is, the generic answer is understanding the difference between what UNS is and what it is not. Okay. Yeah. So that at the end of the day, it boils down to that. But the people who are really unlocking the potential of a unified namespace architecture. So we'll quickly go through again, what is UNS? And if you ever want to see the definition of UNS, you can read any of Kudzai's blog posts. HiveMQ's got a ton of great stuff, but you could also go to virtualfactory.online, and literally the definition is on the website. Like virtualfactory.online contains what is a unified namespace. Okay. So it's the structure of your business and all of the events. Events is the important thing, not all the transactions, all of the events. It's a single source of truth for all data and information. It's the current state of the business, events, data, and information models contextualized and normalized. It's the place where the current state of the business lives. It's the hub through which the smart things in your business communicate with one another. And it's the architectural foundation of your digital transformation initiative. Okay. What's very important to note is that in general in manufacturing, a unified namespace is omniscient and omnipresent. So that is, it lives in many places connected together. So for example, if my unified namespace could live inside of Ignition, when I first start, my unified namespace could be in the tags inside of Ignition, okay? Because that might be the limiting, that might be everything that I have is contained inside of Ignition at that point. But you are almost always moving outward to something like a clustered HiveMQ infrastructure. where now I'm dealing with hundreds of millions of messages every minute. Okay. I have millions and millions and millions and millions of topics. Okay. But the unified namespace could live in many places. I could go to this IP address and view it here. I could go to that IP address and view it there. I can also limit it. So if I'm on a production line and I want to see the unified namespace just for this production line, it's going to, the namespace is going to start at line. And then you're going to have Edge, which is going to contain the devices. And you're going to have MES, which is going to contain all the MES models. And you're going to have ERP. It's going to contain the things like the bill of materials and all that kind of stuff. But what you are looking at in a unified namespace, I cannot stress enough. What you are looking at, when you're looking at the unified namespace, you are looking at the current state of the business right now. You are not looking at the transactions 5 minutes ago. You are looking at this moment. The people who get the most out of unified namespace understand what it is and it isn't. Number two, they understand the difference between the real-time state that is in unified namespace and how real-time is used to drive other decisions. For example, now with Agentic AI, I may have an agent look at the current state of my business. We do this all the time. It looks at the current state of the business and says, I'm the supervisor overseeing this area in this plant. Tell me what the current state of the business is and what are my 3 top areas that I need to be focused on. Okay. The agents can do that for you. They can either do that on a trigger, or you can prompt it to do that for you. And what the agent's going to do is look at current state, and then it's going to look at the context in the current state. And it's going to go, I need a little bit more information. I see this production line is running, they're behind schedule. I think the first thing I need to do is I need to take what I've got there at current state, and I need to go query the old work orders. I'm going to use an MCP toolkit to go query the old work orders to look at all the work orders that are from the product code that they're running on that production line right now. Unified namespace is the originating point of the current state, but all the transactions and the history and all the other things you do to make decisions, they're in different systems of ownership, where unified namespace is driving the decision about which data I'm going to go get to learn more. The people who are getting the most out of unified namespace understand the difference between its real-time nature and how it's used to retrieve transactions and history to make decisions.
100%. I mean, I couldn't. It's really interesting that I wasn't expecting that answer, but it's really interesting that you actually mentioned that, because that's exactly how I see it. Because since it's fascinating to me how, since you coined the unified namespace and defined it, there's been several people who have tried to redefine it and kind of like talk about how it should be, right? So first of all, unified namespace is not a physical law, right? To say it should be like this, right? This is something that you define, so it is what it is, right?
Yep.
And in many cases, people try to redefine, then they start to say, oh, actually, it needs to have history, or it needs to have this, it needs to be this and that, and then kind of like get lost in that law. If you really understand what the unified namespace is, it's easy for you to get value, because you basically use it for the right reasons, right?
Correct. If you're not getting value out of it, then you're using unified namespace for something that it isn't. You think it's something that it's not. 100%. Right? You're trying to fit a round peg into a square hole. Like if you think about where unified namespace came from, you walk into any manufacturing facility and you go, where is how many units do you do this a year? Oh, we do 25 million widgets. And if I ask you the question, why don't you do 50 million? The answer is, I don't know. Unified namespace reveals to you why it is you don't do 50. If I say, what's the current state of your business right now? Mr. Supervisor, what area of this plant are you overseeing? Oh, I'm responsible for the assembly of our, let's say, I worked in tier 1 automotive. So in tier 1 automotive, we had punch presses, we had heat treat, we had pin machines, and then we had assembly machines where we made chain for cars. Okay. I'm the supervisor who oversees assembly. Okay. In the assembly area, we do something like 65 products for many different manufacturers, and we have over 100 assembly machines running at any given time. Okay. And if I ask the supervisor, okay, how is your area doing right now? The answer is always, I don't know. Unified namespace solves that. Unified namespace gives you the answer to what the current state of my area is right now. If I say, what work orders are the highest performers right now, unified namespace is the backbone where I go get that. Okay, the work orders are active. I can see the work orders. I can see the state. I can see the top 10 downtime reasons. I can see all the things that I care about to make manufacturing decisions. And even more importantly, UNS allows you to extend the infrastructure to do things that are even non-standardized. So if I'm an engineer who's working on a plant floor and I go, you know what, I want to take a measurement off of this temperature sensor every 10 minutes. In the old days, I would be like, hey, I'm going to send somebody out with their clipboard and they're going to have a stopwatch. And every 10 minutes, they're going to write. No. I'll just set up a functional namespace that's blue. That's mine. I own it. I'll connect to the temperature sensor in the PLC. And every 10 minutes, I'll capture it and I'll insert it into an array that's inside of a JSON, inside of a topical namespace. And now I've got my values living inside my unified namespace. And that's what UNS is. People try to make it. Dylan Dufresne and I have had this conversation a million times because Dylan shares our frustration. Same thing. People try to make unified namespace something it isn't. You know what I mean? It's the single source of truth for data and information. It's semantically organized. It's current state. And there's many things around unified namespace, but unified namespace is the centerpiece. It is state right now.
100%. I think that's also, I think for me, it was natural to look at the unified namespace with all the explosion of agentic AI to say, here we have a sort of like a system that sort of like drives an event-driven architecture within sort of like a manufacturing IT environment. So you've got these microservices like sort of like exchanging information, subscribing to events, and then performing some transactional stuff on the side. So it was only natural also for me to see this as the natural sort of backbone for AI agents, which are effectively microservices, as it were, that perform a specific task, right? And then they're plugged into that state and event infrastructure to receive the context on what they need to do next, and then go off and do whatever it is that they need to do using MCP or whatever it is.
Correct. It is the unified namespace for agentic AI. Okay. UNS provides the real-time status of enter in any topic in context of the business. So if I asked a question of which of my assets are running the best right now, or which 5 assets are running the worst, unified namespace is the place that an agent would go to give that answer. The reason why is because the semantic nature, semantic nature naturally organizes the assets in context of the business. So if I say to the agent something as simple as, I'm the supervisor who oversees assembly in our chain manufacturer, and I've got 100 assets, and I want to know the 10, I can't go visit all 100 assets. Give me the 10 to go visit. Give me the 10 assets I need to go visit right now and talk to the operators. The agent is going to look at the unified namespace. It's going to look at all 100 assembly machines in context to one another. And it will, using natural language, it will be able to go, these are the 10 that are performing the least, because whatever numbers, whether you're using pack to meld or whether you're using OEE, whatever the number is, the agent will know what it means, what the topic means. And it'll say, here are the 10 you need to go look at and why. And then what happens? Once the agent has that context, AI uses what it got from the context of the unified namespace to reason through for objective-oriented tasks. So the initial context that an agent gets when you ask it a question about your operations is the context you give it. The next level of context is what it gets from the unified namespace. The third level of context is what it retrieves from the MCP tools as it reasons through what it learned from the unified namespace.
100%. Yeah, so we're quickly running out of time here, but I wanted to kind of like get your sense on, as we sort of like zoom out and go big picture, so we kind of like understand that unified namespace is that, centerpiece that sort of has the structure of your business and events. So what does the full data architecture look like? So if you were sort of like advising a maybe mid to large manufacturer in sort of like building that ecosystem around the unified namespace, what would that ideal full stack look like for you?
All right, so I'm going to do it in a couple of steps. So step number one is, if we're going to put this in the context of where do I start, and let's say I'm a small to mid-sized manufacturer and we're dealing with just one plant. So the best way to visualize this is you're going to land a server that is exactly midway between IT and OT. It's going to, you land a server that's got dual NIC, one that's connected to the OT network, one that's connected to the IT network. That's what's running on that server is going to be probably Linux. Okay. And you're going to install Docker and you're going to install Portainer. That's the first things you're going to install there, because that's going to give you the ability to deploy applications in that environment. Okay. And then you're going to install Node-RED for your dev tool. So Node-RED is going to get landed, and I might use Node-RED to connect to an OPC server to just kind of get the lay of the land. So those three pieces right there are they're my development environment when I first land. Okay. Mm-hmm. Then what I'm going to do is I'm probably going to land something like Litmus, and I might switch Node-RED to Ergotech, which is a new technology I've been introduced. They're not new, but it's a technology I've only recently been introduced to, and it's kind of Node-RED on steroids, and it's got a whole host of nodes that don't exist in Node-RED, and I'm very impressed with it. So I might swap Node-RED for Ergotech, and then I'm going to land Litmus. Litmus is really marketed as like a data ops information, like a wholesale information platform. But for me, Litmus Edge, the real value in Litmus Edge is basically being able to, is all the connectors it has to talk to all the devices, and how I can immediately like pipe that into an infrastructure. I can take the data from a PLC, I can take the data from a database, and I can bring that together and pipe it to some local place. I'm going to have an IIoT platform, and more. So this is going to be like WinCCOA, Frameworks, or Ignition. But more and more after Frameworks 10 came out, if you haven't looked at Tatsoft's Frameworks 10, total game changer. I absolutely love the new release. And in the last 3 implementations I've done, I'm using Frameworks in the proof of concept. So I'm probably going to land Frameworks. Traditionally, it's been 80% Ignition. And I'm still going to use Ignition a lot, but Frameworks has definitely done some amazing stuff. I'm going to land Timebase in a Docker container. Timebase is a historian from Flow Software. So we're all still in the same server here, by the way. And then the next thing I'm going to do is I'm going to add in two new servers as a cluster, and I'm going to land in HiveMQ. Okay, so in my IoT platform, I'm going to pull that data through Litmus, and I'm going to historize it in Timebase running in a container. And then immediately from my platform, I'm going to start streaming my data into HiveMQ. And so all of the external users, when they want to see current state, they're going to be looking at a HiveMQ broker. That's what they're going to be looking at. Then for data ops, Maestro Hub I'm a huge fan of Maestro Hub. I love HiByte. I love Maestro Hub. You can do data ops in tools like Frameworks, but you really want industrial data ops. That is something that was designed to do data operations. And I'm more and more, Maestro Hub is looking more and more impressive, especially this new release that they just came out with. Then for analytics, I'm going to use Atanta Analytics for citizen developer analytics. I'm going to use a lot of custom Python, running on that server. And then once I'm ready to go to the cloud, I'm going to one of two places. I'm either going to Google Cloud, GCS, Google Cloud Services, using BigQuery and Looker Studio, which is Google's my go-to cloud provider. If I want to sell my data, so say I've gotten advanced enough where I want to go to market, I basically want to package my data for sale, I'm going to use Snowflake. Okay. And then there are 2 other tools that I think more and more are becoming more important. Thread Cloud, I think, is going to become ubiquitous. I think you want to knowledge graph your infrastructure, and I can basically take Thread Cloud, plug it into an MQTT broker. They have an Ignition module. I can pull all the Ignition tags out into Thread Cloud, and now I have the knowledge graph of my entire infrastructure, and I can bolt my agent into that, and then my agent can just navigate the infrastructure. And then the last piece will be for cloud-based analytics for the citizen developer. That is the person who doesn't know how to do analytics in something like Looker Studio, which requires development capabilities. I'm going to use Atanta Prompt to Insights. So that is right now, if you want to know where my stack is, that's my stack.
Great stuff. So just one quick question. So if a company already has something like AVEVA Pi, where does that fall into the picture? I've had, some questions around, do we need to duplicate data from AVEVA Pi? Where does this Pi fit into that picture?
There are in fact, I'm not sharing. There are many examples of existing Pi infrastructures that are using event frames and asset frames inside of Pi, and they are using them in UNS architectures. Regeneron is the best example right now. Regeneron, a life sciences company, did a huge implementation in their research and development facility where the core of all their data was inside of Pi. Do you need to replace Pi? Do you need to replicate? Sometimes you want to copy your history. There are use cases where I want to take the history, the system of ownership for history is inside of Pi, but I may want to write a custom Python script that's going to retrieve history over, say, the last week for a specific data point, and I may want to copy that somewhere else to use it for some analytical function or for an agent to go retrieve, right? So I may want to limit what the agent can see, if I'm using agentic AI in this case, to just 1 week of history, and I may want to copy that. But am I seeing a lot of, like, do I have to convert Pi? Do I need to replace it with something else? No. I mean, I can tell you when I walk into a facility and someone's already using OSI Pi and they go, do I got to get rid of this? I go, no. But limit Pi to what it's good at, and that is the historian component. My opinion is you're overpaying for OSI Pi, and you could save a lot of money by using a different historian, but the OSI Pi is a great historian. 100%. And more since the AVEVA acquisition, Pi has moved more and more open. Now that AVEVA's got the Connect platform, which is kind of like manufacturing data engine for Google, Pi is much more open than it was when it was just OSI Soft who was in charge. So OSI Soft was very, very particular about who could retrieve the data from OSI natively, and they really wanted to limit it to OSI Soft partners. And AVEVA has changed that strategy.
100%. Yeah, just quickly before I let you go, as a tradition on this podcast, I ask our guests to, give us a prediction of, what the factory floor looks like in the next few years with AI. Just, wild prediction. Where do you see things headed in the next few years?
Here's the thing. A lot of people ask me the question, like, are we gonna see a lot of jobs replaced by AI in manufacturing specifically? And the answer is yes, but not many on the plant floor. So we're going to see more people on the plant floor, not less. Okay, and that is not a popular opinion, but we're going to see more people on the plant floor. And the reason why is that the people we're going to see on the plant floor are going to be analysts. You're going to have more and more human analysts supervising AI to optimize operations on the plant floor, and you're going to see a lot less middle management. You're going to see a lot fewer people managing people, and you're going to see a lot more people managing AI agents. That's how the plant floor is actually going to change. Over the next 24 to 36 months, primarily what we're going to be seeing is a very incremental adoption of AI on the platform centered around two things. Number one, using AI to help you build things. And number two, using AI to do a task you specifically assigned it to do. Not the business, but you. And it's going to be all about making you better at what you do.
Volker, this has been such a fascinating conversation. Thank you so much for taking the time to join me today here for your insightful conversation. And we're going to provide links to all the IIT.university and all the various workshops that you're currently conducting right now for people to check them out, and also the link to the Discord server. It's a great resource of information for a lot of people who are going down this path of digital transformation in manufacturing. So again, Volker, thank you so much. Really appreciate your time here.
Appreciate you, brother. Thank you for everything you do.